Hello. So today I'm going to be talking about representing a sensitivity analysis for the stock model that I created for Viasat. So first thing that I did was determine kind of how do you represent data based on numbers and showcasing what is important, and a couple steps that I found from the site on communicating numbers talked about determining what the message is and what data you need to convey it, determine what type of visual representation, which variables should be shown, and then how much the data should you show. So I kind of kept that in mind as I created graphs for each one of these analyses. That way I was able to kind of think through what kind of graphs would be most useful in representing the data. So first of all, after doing my current stock model, I came up with a price of 72 cents. And when I got this, I knew it was pretty unreasonable considering that Viasat currently has a stock model price of $62, and ever since their stock became public in 1996, it's been a pretty increasing trend. Yes, they've had their drops and their ups and downs, but overall the price has continued to increase, so I find it very unrealistic that in the next 10 years the price is going to drop down to 72 cents. Some reasons that I thought that this could be the case was not enough historical data for the accurate forecast. The assets are mainly represented in other forms, and the discount rate is not accurate because it is a risky market, and the beta values for the other companies were kind of up and down, so finding a discount rate that works for them might not be as accurate as whatever they are using. Or the company could just be overvalued for what they're worth. So first thing that I did was gather data farther back to better estimate a forecast. I figured that if I went back another 5 more years, I could potentially fit a trend line with dummy variables that make more sense, or could potentially increase the stock price. And then using the dummy variables in the future forecast, I figured depending on how you forecast the future, that could potentially change the stock price. And then beta changes for R, and then reinvestment changes. So these are the areas that I looked at when comparing a sensitivity analysis to find out which change would make the largest difference in the stock price. So first of all, like I said, I went back and forecasted data going back another 5 years, but that actually made my stock price worse and made it -3, almost -$4. However, the trend, as you can see, is about the same. So the blue line is when I went back and collected 5 more years of data. It's lower than the orange line, but the trend is overall the same due to the forecasting and the dummy variables. So I decided not to use the adjusted forecasted equation, and just used my normal model. And then going through figuring out a graph to compare this, since it is over a time period, that's more of a continuous function rather than a nominal function. So using a line graph was my best option because you could see how the two models compared over a period of time. So the first thing I did for sensitivity in the forecast was by adjusting my dummy variables within the 10 years. I had 3 segments that I looked at: commercial, government, and satellite. And for commercial, there were some positives and some negative variables based on the time of the year and what was happening in the history of the company. So I took one of the positive variables from when they acquired a company, and then I also took the average of the 2 negative variables for when they started losing money. And so those were 2 different dummies. And then the government variables, there were 3 or 4 negative variables based on other things, losing different programs that they had thought that they were going to own, as well as some tax breaks that they ended up not benefiting from. So I took the average of those 3 or 4 dummy variables and came out with 17,000. And then satellite had 1 positive dummy variable, and that was 8,900. So that's where the dummy variables came from. And so what I did was, as you can see in the bar graph on the top side, on the top one, I looked at just commercial, and so that included using both of the variables, just government using 17,000 twice, and satellite variables using 8,000 twice. And then I did just the first set of variables for all 3. So these variables happened a couple times during the 10-year historical forecast or history data that I found. So then I used them once using the top row, and then once using just the bottom row, and then once using both of them simultaneously. And so that's where you get the top bar chart from. And then looking at the bottom one, I decided to see, okay, the top one shows me what the stock price was using those variables, but how does that change from the current stock price? So using a deviation from the current price is actually something that I looked up from that same article that I found on tips for showing numbers, and I thought that doing a deviation would make more sense because then it shows how the stock price changed, not just what it changed to. So the scale for these ones are both the same. However, this bottom one shows the change based on what the current stock price is. So just government, the price, as you can see, is almost like 30 cents, but since the current price is 72 cents, that's a drop in what the price would be. So overall, though, looking at the scale of this graph and looking at where the current price is, even the higher ones, that's either just commercial, just satellite, or the first dummy of all three, you can see that the change in stock price is really only about 30 cents. So it's not a huge change in stock price when it comes to adjusting how the forecast is. So next I looked at the discount rate, which we used beta values and liabilities and the market values in order to find. And the current price right now, it says 7%, it's rounded up, it was like 6.8 or 6.7. So I changed that by going down a couple percents to 5% and up a few percents to 10% and watched how the stock price changed. And so as you can see, as the discount rate increases, the stock price drops. Again, I decided to use a line graph because it's a change of percentage. A bar graph would have worked too to see the progression of it slowly dropping, but I think the line graph shows more of the slope of how it drops with the discount rate, which I will go into further at the end of the presentation of how the slope can show you what the most sensitive variable is. And so the next I looked at reinvestment changes. First I looked at changing the rate of return percent, so how much the interest rate would change. And so it started at 10% and I went from 10% down to 5% and then up to 15%. And as you can see, as you increase the return rate of investment, the stock price obviously goes up. But again, it only changes up to about $1.60, which currently it's at 72 cents. That's not a huge change in stock price. And then the bottom graph shows what happens when you change the stock price reinvestment amount. So when I found on their 10K form was last year they reinvested about 30 million. So I was using that as kind of my standard, but I dropped that down to 500,000 and up to 80 million. And again, you can see it doesn't increase much past 160 or $1.60. So again, that's not a huge change in stock price, but that would make sense because your reinvestment layer is just a small portion of what your stock price is made out of for the present values. So overall, I wanted to find a way to how do you compare all of these different variables to show which one makes the most sense. And so using a spider graph, it's hard to kind of see the second two for the reinvestment rates, but I changed them all 5% lower and 5% above, so a 10% overall change. I kept all of the same starting points as I did in the other comparison, so the discount rate was at 6%, reinvestment rate was 10%, and reinvestment amount was 30 million. And I varied them all by an equal percent. And as you can see, the discount rate, this orange line right here, has the largest slope. So that's where we're going to find the most change in our stock price. Whereas the other two, you can barely even see the reinvestment rate behind the reinvestment amount. But those changes are so small compared to the discount rate that no matter how much money you throw at reinvesting or the rate that you change it to, really isn't going to make that much of an effect on the stock price. So the discount rate is definitely what you would look at in order to try to increase your stock price or watch your stock price in case your discount rate starts increasing, your stock price is going to drop even further. So that's what I have for my continuation on in the class. If you have any questions, feel free to ask me. Thanks.